Standard deviation is another one of those things you must work out on your calculator, or at least I highly recommend you work out on your calculator, because it does it for you. Okay, so back here we're back on the same 1var stats I had before. You can see the mean is still there at 26.25 over here. And if you, I'll just try focusing that a little bit better. That's a bit better. If you keep going down, there's the sum of x. That's the sum of x squared. And that there is the standard deviation of this data set. So the standard deviation of this data set is 6.75595, which you would normally round off. But that's all you need to know how to do. There is a fancy formula in your book, but you don't need to worry about it. Just use your calculator, and that's how you work it out on your calculator. Menu 411, and it comes up as that symbol there, SX, so standard deviation of x. So once you've worked out the standard deviation on your calculator, you can start applying this rule, 68, 95, 99.7 rule. Now quite simply, your distribution must be something called a normal distribution, okay, which for us laymen is bell-shaped curve, okay. It must be symmetrical, it must look like this, okay, and what it means is across your whole data set, your mean, your mean, or your average, or your x-bar, or whatever you want to call it, is there, okay, and we split it 3 groups either side of that mean, okay, and each of those groups is a standard deviation. One standard, one standard, one standard, okay, and the same on this side. So each of these groups is one standard deviation. A normal, distributed, if I could spell, 6 standard deviations, okay, and those standard deviations mean things. So if you go 1 standard deviation either side of the mean, you have approximately 68% of your data. If you go 2 standard deviations either side of the mean, you get 95, or approximately 95% of your data, and I'm pretty much sure you can guess what's coming next. If you go 3 standard deviations either side of your mean, you get 99.7% of your data. So what does all of this mean? It means you can work out, when it comes to questions on this sort of stuff, you can work out if they give you the mean and the standard deviation, you can work out approximately how many of a sample or something like that actually lie within a certain range. So we might run through a question now. Alright, so here's our question. Our mean is 65. Our standard deviation is 14. As soon as you see mean and standard deviation, guys, in a question, I want you to draw a bell-shaped curve. And I want you to fill in the values. So our mean is 65. Our standard deviation, we always draw the same graph. Okay, even if it's only a rough sketch, it doesn't really matter. This is pretty rough. Each standard deviation is 14. So 65 plus 14 will give me this value here, which is 79. 79 plus 14 will give me this value here, which is 93. And 93 plus 14 will give me this value here, which is 107. If we go back the other way, it's 65 minus 14, which will be 51. 51 minus 14, which will be 37. And 37 minus 14, which will be 23. So we can work out what all of our data set is. Now this particular question said what values will approximately 95% of our data lie. And I'll shift that up a bit so you can see that. So we know that 95% lies within 2 standard deviations of the mean. So 1, 2, and 1, 2. So we can work out that it's going to be 95% of our data between 37 and 93. Okay, so values 95%, approximately 95% of our data will lie between these two. Now, there are things they might ask, so what percentage of our data lies above 51? So what percentage of our data lies above 51? What I want you to know is that above and below the mean, there is 50%. Okay, above and below the mean, there is 50%. If in here there is 68%, and you halve that, then each of these sections is worth 34%. We can break that down even further and say that this next section out here is 13.5%. And then the next section out is 2.35, which leaves 0.15 out there and 0.15 out there. So you can work out that if what roughly percentage lies above 51 is 50 plus this 34, which is 84%. If I wanted to work out what values lied below 51, I could either do, well, I know that's 84, I could minus that and therefore it's 16, or I could add 13.5, 2.35 and 0.15 together. So I'm going to rewrite that neatly now, or a bit neater anyway. There you go. So in each of the middle sections, 34%, the next section out each has 13.5, 2.35 for the next one, and 0.15 for the outer layer.